Hello everyone, welcome to this lecture on AWS Lambda and serverless computing. Let's quickly move and understand what offerings AWS is making in the field of computing. We know that AWS is offering around three major services for compute in the field of computing, that is Amazon EC2, that is Elastic Cloud Compute, then Amazon ECS, which is a container service, and Amazon Lambda. The first two of them are based on, like, you have the full control on the operating system, you have the full control on the background hardware, and but you have to manage the whole scaling. But Amazon Lambda is something totally different. Now you just don't have to worry about the background hardware. You don't worry about the scaling feature. You just don't worry about how much the cost you're spending to keep them idle, or what is the uptime, downtime. You just don't have to worry. The only thing the user has to worry when dealing with Amazon Lambda is the coding that you have to do. Till now, EC2 and ECS were quite powerful, and Lambda is a little weak in comparison to both of them, but it has its own distinct features which make it quite attractive. Let's quickly see. As I've already iterated, that it's serverless computing platform, and it also responds to events such as triggers, which is quite unique. So in real life example, in real time projects, you will see that Lambda is being invoked from different triggers. Suppose you add a file into your S3 bucket, you invoke a Lambda. In some case, there is some change, a new record is added into your Redshift table or your DynamoDB table, or a record is deleted for a particular user, a record is deleted. Then it can also trigger a computing service, the Lambda, that you will code what particular piece of logic that you want to execute. Here are some important benefits. Before we move, we should know there are no servers to manage. Exactly. You don't have to worry about what was the hardware and the scaling, and you just have to worry about your piece of code that you have to write. It scales on its own. Again, if the load is increasing, one Lambda is getting insufficient, then another you can say a concurrent version is running up. How to increase that versions? Multiple Lambdas also running to incorporate your load. These type of things is being handled by the AWS itself and not the user. One of the very important factors is there is no idle or cold servers. The user doesn't have to worry. He has to just set up a trigger, the timing for which he wants to run the Lambda job, and his task is done. Rest of the services, rest of the backend activities is being dealt by AWS itself. Now coming to the costing feature. As we also know that the EC2s are quite costly because you have to maintain them. You have to purchase them for a reserved instance, or even you have to take for like on-demand instance. You have to spend a lot of cost, and for the storage also, for the compute time also. In this case, AWS is quite generous. Here you get a very cheap and highly powerful computing service as compared to EC2s. So it's very important to understand that it only calculates for 100 milliseconds. Like it calculates, like I will rephrase it, it calculates in the intervals of 100 milliseconds. So suppose your job runs for only 60 milliseconds, it will charge you for 100 milliseconds, and going forward in the multiples of 100 milliseconds. There are no hourly, daily or monthly charges. There is no per device fees and nothing else. And even if you're keeping your job like a Lambda function idle, there is no charge for it. Only time you run it, you get charged, that too in the multiples of 100 milliseconds. That is, the minimum is for 100 milliseconds. Just a quick fact that in free tier you get around 1 million requests per month and 400,000 GB seconds of compute every month. So that if you have a free tier account, you can go and practice as much as you want. Now coming to working with Lambda. So the Lambda offers a lots and lots of different languages these days. New languages are being continuously added. Some famous languages in which you can code is Node.js, Java, Python, Golang, C#, PowerShell. These are some common. There are other 2-3 also, but these are the major languages in which you can code. Also, you have the range to select. If you see, earlier it was around I think 1.5 GB. Now it is increased to 120 from 128 MB to 3 GB. So if the memory requirement for the code to run is between 128 MB to 3 GB, it will run fine. Okay, the CPU and network is also allocated. It's not only the RAM which is allocated. If you increase the RAM, the CPU and network is also allocated accordingly, and these adjustments are done by AWS itself. It's not the user who has to worry about it. Even though the RAM adjustment is dynamic, but if you think that like 128 GB is like that is the by default the minimum. Suppose you want to use like 1 GB, then in that case the CPU and everything will be adjusted. And also in the CloudWatch metrics, if you see the dashboard, you can see like how much was the time for idle time, the run time of the Lambda job, and how much was the CPU utilization for the whole run of the Lambda execution. So you will get a full dashboard in the CloudWatch to monitor each and every metrics related to your Lambda function. Programming model, you have to build in the AWS SDK. Your front end is the Lambda, and in the background process will be your threads which will be running in the sockets. Also, apart from writing the codes directly into the Lambda, you can be authorizing your codes to different modules. Like you can also upload to like in the S3 bucket. Also you can write you can zip your code and upload it to the Lambda function itself. But there is a limitation, like the code has to be max to max 50 MB for a zip function. Also, there are plugins for Eclipse and Visual Studio, and you can also access Lambda from the command line interface. The Lambda can also be integrated with AWS S3, RDS, and other non-relational databases that we have already discussed, that how the triggers work actually. And monitoring and logging, I have already explained that you get each and every metrics in the CloudWatch. Now let's discuss the common use cases in the real-time project scenarios. So if you see, the first is very important, that is the data trigger. This happens mostly when you use your S3 buckets as the landing areas, and your rest of the jobs are like dependent on the arrival of the files. Your S3 bucket acts as a file watcher, and whenever the file, it is the first step of the starting of any project or any module. Your file is coming in the morning, and after that some compute, some type of a piece of code needs to be run, some validation or some sanity checks on those files needs to be done, and in further these files will trigger the, you can say, a glue job, okay, or some jobs, or load the data into the Redshift clusters. In that case, these act as a data trigger. Also, for big data analysis, like the live streaming of data through like real-time monitoring in Kinesis Firehose, it's being done, or you can say some IoT devices or IoT sensors are capturing the data in real time, or making API calls from the AWS API, and these data are being then used for some computation. Suppose IoT sensors are there in some cabs, okay, and they are moving from one location to another in real time. These APIs and fire hoses are tracking those GPS locations, and you are there to calculate the distance for the calculation of fare, for the trip fare. If you see, in that case, these things are utilized by the cab service providers, like the major cab service providers, so this is how big data is also coming into picture for Lambda. Also, then if you see control systems like customized responses, like the state changes are there, which I already told you. Like suppose a user is there in the DynamoDB table and that user is now deleted, so the client needs to be like informed about those things. So you, or maybe after the user is deleted, you want to make an entry into some other table. So if there's a change in rows added or deleted, or a change in the state of the tables, then you can also trigger Lambda. Also, the last one is serverless execution. It's simply like, maybe your job is to run every day in the morning and do a piece of like a code needs to be run every morning or every month, something like this, which doesn't depend on any sort of trigger, but that needs to be executed. So you can independently run those logics into your AWS Lambda. There are certain restrictions when we consider the AWS Lambda, and these are very important if you are going to attempt any of the AWS Certified Solution Architect or AWS Developer exam, or even maybe if you're going for SysOps exam. You have to remember this data, you have to remember this slide, which is very important. The first thing is the memory allocation. The minimum is 128 MB, it's to almost 3 GB. That is, if your code requires heavy usage of memory, then Lambda will not be a choice. Second is function timeout. Your earlier it was around 5 minutes, now they have extended it to 15 minutes. The maximum AWS Lambda that can run is for 15 minutes. If your job is a long running job and you want to convert into AWS Lambda, then it's not possible. Then you have to again go to Amazon EC2, or you have to go for Docker services in ECS. Now, the environment variables which you use in this Lambda is maximum of 4 KB. Also, which I was telling, like you can use deployed packages to directly upload your code into this AWS Lambda, which is very common. Like for PowerShell, C# PowerShell, you can't go and write your code into the AWS Lambda. For that, you have to write a code in the PowerShell, and then you have to zip it and upload. Or suppose you are working on certain libraries of Python and they are not available in AWS Lambda. In that case, you have to zip it and upload it to the AWS Lambda, which is having the maximum size of 50 MB. And the temporary directory size, suppose you're also accessing some file and that file needs to be brought into the inline memory of AWS Lambda, that has to be maximum of 512 MB. And the most important is the maximum execution, concurrent execution or the concurrent threads of AWS Lambda is around 1000. That is max to max 1000, you can say roughly concurrent executions of AWS Lambda is there. So before you move to implement your logic into AWS Lambda, you should keep these limitations of this service in mind, and you have to choose wisely that finally you want to go to an Amazon EC2 or ECS, or you want to stick to this AWS Lambda. So I hope this theory was quite clear to you, and it's self-explanatory. And now we'll quickly go to the hands-on and see how Lambda works in real time with an S3 trigger.